Crewton's House of Math.
Crewton Ramone's House of Math.
Crewton's
Anyway.
House of Math.
Alright, so here's what we're doing. Now he's building an addition now. Did you get the whole thing?
Yeah.
We're building a house here because what I see when we're doing multiplication, what did we do? Like 16 times 7, and then he was having a hard time with the addends because he had to add the 4 and the 7 to get 11. Well, actually, 11 tens. So what we're doing is, because we practice this in numerous ways, we're building a house. Pretty soon the roof is going to go on. What goes over here? Building a 12 with a 5. What should I put there?
8.
Get an 8 there. Come on. And see, this time we got multiple blocks, and so he's in hog heaven. Really? So 8 and 5 makes 12.
7 and 5.
Aha! Okay. Right? Remove the no from the lesson. Put them in a situation where they can't fail. Whoops. I'm putting it this way. So it's out.
Yes.
Okay. So he's got a very precise manner of building this house with everything. So there's rooms. If you look down there, there's like even a doorway in there. That's pretty creative. And what's that you're building over there? The entryway.
Yes.
Which is 4s. Whoopee, we can build 4s. I want you to build 13s, and we have another 13 there, and 12s, and there's a 14, and then look, he's building some 10s. So build that up. And then maybe we could make some 11s when we get the next layer.
7.
7s. Okay, so you got 7 plus what is going to make you 13?
6.
There you go. So he grabs a 6, puts it on there. Alright. So it's Friday. It's a more fun way of learning the addends. We're taking it easy after you just aced that other test that you did. Right? 17 question test, you got basically a 94. He was all happy with that. And I was all happy with that too. And then we can learn stuff about, addends in an easy, non-threatening, more fun way. I was looking at some other guys that were supposed to be using manipulatives to teach math, and they didn't use any manipulatives to teach math. Hey, could you build me some rectangles real quick? I'll tell you what, build me this build me a square out of
5.
Good, a 5 square. You read my mind. A 5 square, a 12 square, and a 13 square. Just for fun. Okay, so there's your 5 square. Oh, just a square.
Oh, okay.
And then a here. Use this to make your 12 square. We're gonna make a triangle out of it. Wait a minute. Use the edge. Yeah, square. It needs to be square. So 12 square. We're going to fit in the corner there. And see, when we talk about completing the square, it totally makes sense. Yeah, we're going to have a difficult time fitting everything on the table. Pirate patch. Alright, we got to fit it all together. So we got the 5, got the 12. Uh-oh. We don't have room.
Yeah, we do. We could just go upwards.
We could move this whole thing.
No.
Well, we could put this over here. Let's move that. Let's put it over here. I'll put that over there. Ugh. Hold on. Let's get this all rearranged. 1.
Now we're back.
There you go. He did it twice perfectly. And then when the camera was rolling. Okay, wait. So what do we do? What do we have over here?
A triangle.
A triangle, but not just any kind of triangle. It's a Pythagorean triple. And we can actually look at this, and we can get our hands on it, and we can see that this side is 5, and this side is 12, and this side has to be 13. And this is a 13 square. How much in a 13 square?
13 times 13.
Count it. Look. Even though we got
169.
Excellent. And then what do we have in our 12 square?
142.
How many?
144.
144. Got to count both of these guys over here, right? And we can see that it really does. It makes a triangle. And if I square that side and I square that side, add them together, what's 25 and 144?
25 and 144.
Which is part of the reason why we're doing these add-ins over here. Yeah. Tell me. What's 25 and 144?
25 and 144 is...
Can you add them in your head?
Oh, they're adding? I thought you meant multiplying.
Just adding.
25 and...
Add this and this.
Okay.
We're adding 144 and 25. Now, for those of you that know Pythagorean theorem, you know the answer already. It's staring him in the face, but he doesn't know it, so we'll make some discoveries. 25 and 144. Write it down if you have to. Oh my gosh. Here, there's a pen.
Yes.
Very quickly. 144.
669.
What's that?
169.
What's this?
169.
So when I add this together and this together, it's the same as that. Right? And then I square root it. What does square rooting mean? Ah, you're knocking down the thing. What does square rooting mean?
Multiply by itself.
Oh, that's squaring. What does square rooting mean? That's a good kid definition. Multiply by yourself to square, right? 5 times 5 is 25. But when I square root, what do I have to do? Like if I want the square root of this 25, what do I have to do?
25 times 25.
What?
25 times 25.
Is that the square root of 25?
No.
What's the square root?
5.
What's the square root though?
5.
Square root of 25 is 5. What does that mean? Look over here and tell me.
5.
So the whole thing is 25. You told me 5. So what does that mean?
It's 1/5 thing.
Okay, in this case it is, but it wouldn't be 1/5 of this thing.
Right.
So what is it?
It's a part of it.
It's a part of it. We have the whole rectangle is 25. Well, actually the whole square is 25. And 5 is one side. So when I square root, what do?
You take it and times it by itself.
Okay.
Times it by itself.
That's when you square it. But when I square root it, can you make me a square root symbol? Oh. There, use a better pen. That pen's obviously pretty weak. I don't know if that's a better pen or not. Let's see. Make me a square root symbol. Oh, that's good. Okay, so that's square, right? 5 squared equals 25. That's that thing right there. Give me a square root. Square root. That's the symbol for square root. See it?
Yeah, divide by 5. Goes 25.
Alright. But what if I had square root 169? What's that?
144.
Yeah, cap the pen so it doesn't dry out. The square root. See, there we go. We have no understanding at the moment.
13.
Okay. Oh, okay. Oop, did you hear the light bulb go off? Okay. So yes, it's 13. So what is it? It's one side of this square.
Alright.
So write 13. Oh, look at him all writing super nice. Okay, cool. So give me the square root, right? Square root 144. And that's what?
12.
Excellent. Okay, so all we're saying is that I can make a rectangle where, excuse me, not a rectangle, a triangle where the sides are 5, 12, and 13. And it works out nicely. What kind of angle is that right there, by the way?
Alright.
Why is it a right triangle? Oh, because it's a right angle. How many degrees in a right angle?
90.
Excellent. They did spend some time doing triangles. So if that's 90, what do you think this angle is? Probably. About.
A cute angle.
Excellent. He gives me the history answer. Okay, but I want a more precise. Give me a number. What do you think it would be? This is 90. What do you think this would be? Oh, Brad, and you know how to use your super cool tool and figure it out.
Sweet. But, dang it.
Because people are trying to tell you that you can't use manipulatives to do geometry and learn trig and stuff. And that's the most ridiculous thing I've ever heard.
Okay.
What do you think? About.
It's about 25 degrees.
You think it's 25?
Yeah.
Okay.
You have to go that way.
So, What do you think that angle is going to be then?
180 plus 25. Oh, 90.
Oh, look at that. He's not even going to measure it. He's doing some math to figure it out.
Yes, okay, so I have to bring that all the way up to 180.
Oh, that's a good way to think of it. Let's see, he's just doing some simple math in his head because he knows that it has to be 180.
65.
I think it's 65. Okay. Because normally we're off by a few degrees because of the way this is. This would be 90, this would be 30, and this would be 60. Right? But since you had 25 here, measure it just to see, just for fun, and see if we did have it so that it's off. Put that, and this is where the problem is. Put that point right there at the point. Line up the lines and tell me what you get. Maybe you want to line it up this way.
Yeah, and then we get like 69, 68.
Okay, so we're looking at that. So we're off because our angles are not perfect. That should be 60, but it's off by a little bit, right? And this should be 30, but you're right. So that one had to compensate for this one being less. That one had to be more. You know what I mean?
Yep.
Since this is only 25, then that had to be 65. See, we know these relationships already. In a perfect world, if we could set these blocks up nicely, we know that we know what the angles are. And Pythagorean theorem helps us figure this thing out. So anyway, just fooling around with this perfect triangle, and then we have some experience with it, so that when can I draw a picture?
Yeah.
Actually, you're good at drawing pictures. Draw me a picture. Over here.
What?
Draw me a picture of a triangle like that. Just exactly a right triangle. And then label sides 5, 12, 13. Doesn't have to be to scale. And there it is, drawing it. So, okay, I don't care about the angles. I want to know about the sides.
Oh.
Ucha! That's fine. So what's that side supposed to be?
50. Oh wait, no. That's supposed to be 12.
Yes. And what's the other side supposed to be?
13.
There we go. And what's that supposed to be? Alright. So there's our drawing of it. Drawing not to scale, right? But there is actual physical reality where we can see what we're talking about. And it's a little more complicated and more fun than 3, 4, 5. Alright, so back to the house. Gee, while what are we learning? Math concepts. He's building addends for 13, making it higher and higher, and addends for 4. Woohoo! And addends for 12. And let's put the roof on.
Wait, I'm not done with this side.
That's what I mean. Let's put a roof there and build up. Put something else on. We know what's cool in the underneath, not here. We're making split level. You're in the house of math, man. We're doing all kind of cool stuff. All right.
Oh, I know what I'm gonna do.
You know what you need?
Yeah,
you might. Okay, that. Or we could use some supports. Oh, that's cool. Wait, bigger. You know what you could do? Make a balcony.
Yeah, that's what I'm doing there.
You know what I'm saying? Here, put some 4s over here. And stretch it out. There you go, and then put it. Okay. And now we can build a new layer.
Wait.
Whoa. I'm putting a 4 down here so that it's got some support. So we need a post there.
Okay, now I can destroy this.
Alright. Okay, so now let's not make it 14. Let's make it like 11. So that there's like a... It's more cool when there's like balconies and stuff, you know what I'm saying?
Okay.
Here. Make it an 11. And then let's go that way, a ways.
How much?
I don't know, what do you think?
All the way to the edge.
Well, maybe not that far. Again, make a balcony or something.
No, I want to make a 9.
Make a 19. There's no 19s for addends. This is where we have to control the... Okay, how about 17?
Okay.
Oh wait, how about 16? Do we have any 16s in the bottom layer?
No.
Alright. So, why did I pick a note, right? So we just get practice building all the addends. And then we could build a 7. Anyway, you get the idea. Oof, look, it's getting to be pretty cool. There's an entryway over there. We gotta get some little men or maybe some cars. This originally was gonna be a garage, but it's turned into, what is it now?
House.
It's a house?
A full-size house.
Okay, with multiple levels. What happens with this house? Is it a house of math?
Yes, it's a house of math. Wait, how high did we say we were making it?
Well, we're already there. That's done. So we could put another layer on over here.
Do you have more of these things? Because I need it.
As a matter of fact, I do. You have to ask really nicely.
Can I please have one?
Okay, and then we got a couple more trays out, right? So that we can. All right. So anyway, we have lots of blocks to play with. But do you see? It's just fun. I'm just fooling around. There you go. All right. So 11, 9, and 2, etc. Okay, wait. Let me get more blocks.
Ooh, this one's sick.
Pretty cool, huh? When I was a younger man, they actually made cars like this come off the production line. This one and that one. In fact, my friend had one of these. Camaro, Firebird. Oh, that's a Camaro. See? The old school Camaros.
Okay, wait, let me build it.
Alright, so we've got a upstairs parking garage going on. This guy's totally out of scale. How could he even get in the cars? You have to get like little miniature men to get in there.
Cool.
I think 1/32 scale or something. Anyway, so we've got that going. We got this. What are we doing? We're just playing, having fun. But at the same time, can you build me some 16s? Put this wall up. Get that wall going. We got construction to do, man. And over here, what do I have? If I have the 8 and the 4, what am I going to fit on this? Whoa!
Oh, sure.
Oh, careful. 8 and the 4? That's 12. We're going to go with the 9. Here, I got it. Juke. That wall over there needs some work. Alright, well if you're going to build it that way, let's make a new thing. 10. And how much to get to the end? What do you think? You got a 6?
Yeah.
Any more 6s? There's a 6. Alright, so there's a 6. So look, we got 2 16 walls going. Oh! Never mind, it's a window now.
We need support. Rebuild.
We can rebuild him. I'll put a 9 there.
That is the main support.
Okay. You know, we got this dangerous looking hole right there. What happens? The cars fall off.
No. No more dangerous hole. Just a really bad repair.
Oh, I think we should put a...
If you go in there, it's a little...
5s.
It's a little...
Could we put one more 5 in there, maybe?
Yeah, boy. It's a bad support if you sit on it.
Okay. Maybe we could put something else on it.
There. That should hold it up.
Yeah. Okay. Anyway, so push that car and we'll see what happens. It bottoms out. Oh, keep going now. Push it a little more. Oh! Ah! Okay.
I'll throw it.
Alright.
I know what to do now. So it doesn't die out.
Alright, so put a wall up or something. Ugh. Alright. Good, now try it. Yeah, just see what happens. Here, I'll put this one.
We're coming down. Oh, he doesn't bottom out.
He doesn't bottom out and he doesn't stay on either.
Boom.
Oh,
He breaks the
good
wall.
stuff. Okay. Let's get back over here and build some more. Go up, go up.
Okay.
Some more combinations for 16. Already got 10s. Already got 9s. What can we use? 8s. Another one. Oh, cool. Alright, just playing blocks, having a good time. And you notice also, as you're going, you got to direct it so that it's not just 100% playtime. There's actually some learning that goes on. And what we're trying to focus on here is addends past 10, right? Get all the 45 addends down. This kid can do third power algebra. You can see there's a test where if you took the test that was 17 questions long, was algebra that I guarantee you some adults would have a hard time with, and he'd whip through it no problem. But we still have basics that need to be mastered, where he knows, you know, what's 4 and 7?
4 and 7?
Yeah.
7 plus 4 is 11.
Okay, with less thinking than that, right? It's not total recall yet. And just recall that a few lessons ago, he was still counting on his fingers and he had no ability to do what he just did. But pretty soon it'll be to the point where he doesn't have to think about it. And how do we do it? We just practice over and over again, right? I was working with a student who was studying today. She had a final exam in algebra. And we were supposed to be reviewing. Problem was we weren't reviewing, we were spending quite a bit of time teaching over again, because she hadn't had enough exposure. So she took a test before this, passed the test, and then forgot it instead of being able to do it. So it's the same thing with the addends. You have to practice them over and over again, whatever concept it is, at least 18 times, right? So that means you need to be able to do each kind of algebra problem. I mean, how many times have we factored x squared, 5x, and 6? Lots of times, right? Okay, and then we started doing negative numbers, and then we started fooling around with higher powers, and we managed to get to the point where, you know, that's not a problem, it's not scary. But still, we'd have to get basics handled like addends. And so right there, building addends for 5. Right there, building addends for 4. Right there, building addends for 16. And just practice over and over and over again, putting it in the mind. And then when we get pencil and paper out, it's super easy. Now, for 16, it's pretty boring, right? Because there's only 2 addends.
9, 9, 9, 9, 9, 9.
Right? What else can I use? 7 and 9, 9 and 7, 8 and 8. You can use them in 2 different combinations, but that's it. That's the only combinations there are for 16. 16 is a pretty easy number to build.
8.
And it's pretty cool. But you know what we didn't do? We need a balcony going around the edge here. Because how do we? I know, but how do you get there?
Oh, stairs. Watch.
Okay, cool. We'll build some stairs.
It'll be 4. Crewton Ramone's house.com.
There it is. Yeah, I got it. Okay, so here's a short little thing. What we're doing here is, this was started off as working on addends. So building 12s and building various numbers like 16s and building 13s and building 14s. And why do we do that? Because we were doing multiplication and he was having trouble with single digit times 2 digit multiplication because he didn't have his addends down. So we're getting the addends down. So now, what's 7 and 4?
7 and 4 is a 12. Wait, no, it's 11.
There you go. What's 8 and 8?
8 and 8 is 6. Wait, yeah, 16.
What's 7 and 5?
7 and 5. 7 and 5 is 12.
There we go. Look, there they are. We've built them already. Okay, so let's set up for some algebra, for some simple algebra. Let's see here. How about on this side where I say 6 plus x equals 14. What does x have to be? If I'm making that wall over there 14 and I have a 6, what do I need?
If you're making a 14 wall,
yeah,
and you have 6,
yes,
you need another 6.
To make 14?
Oh, wait, no. Oops, I mean 8.
Yeah, there you go. Okay, that's just simple algebra. Is that enough, right?
This thing has a clearance of 4 feet.
There you go. We've got the cars.
5.
And there, and we can see all kind of fun math going on here. Right? It's Friday, and we're just kind of playing. You want to see the whole lesson? Go to Crewton Ramone's house.math.com for more.
Bye-bye.
Alright, so now we're getting really crazy, putting on another level. But let's look over here for a second while we're playing that. Okay, what plus 4 equals 12?
Huh? What plus 4 equals 12?
And we have them over here on the wall. But anyway, what plus 4 is going to be the same thing as 12? In fact, there's my 12 wall right there. On this side, there's another 12 wall on the other side.
What plus 4 equals 12?
Yes.
8.
Very good. Okay, now you did that. What did you do? Did some subtraction, I'll bet you, in your head. Or were you just trying to remember the combinations? But here, let me show you how we're going to do it. Over here, right, people say, oh, we'll just subtract 4 from both sides, or they come up with fancy names where we use the inverse addend. No. Here's what we're going to do. Do you see same on both sides? Hey, quit fooling around for a second. Come over here and look. Alright. Do you see same on both sides? Can you see in your mind same on both sides when I just have the symbols? Let's get an X up. No, let's just draw it. I have an X. 1, 2, 3, 4. Is there 4 over here?
Nope.
Sure there is.
I mean, yes.
Right?
Yeah.
Is there?
Yes.
4 and what? Well, I have 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6, 7, 8 makes 12.
Yeah.
Right? So I just take the 4 out of both sides. Take 4 from here, take 4 from there. And it's easier with the blocks. Look, little kids enjoy doing that part. X equals, what? 8. Here was 0, no fun, get back to 1. But this is why we use the addends. And this is why doing stuff like this, it totally will make sense when he sees it. Because we've already played with, you know, silly looking houses like this that looks like we're just playing around and just fooling around with blocks. But a lot more can go on there if you direct the discovery and help them. Right now we're just fooling around, right? Putting up a couple of walls and so forth. But while we're fooling around, we also get a lot of math learning if you give them instruction. And like even over here, look at this part. Oh, counting by 3s for the little kids. Counting by 6s. We've got a staircase where we have to count by 5s. Right? 5s are super easy.
And a windbreaker.
And a windbreaker, so that they can come in, right? Use your, and also what gift it is to get them to use their imagination. Look at over here. Look at that wall. Oh yeah, fun stuff. Okay, so over here was the learning part, the 13s. And over here was still a learning part, making 4s, but 4s are pretty easy to build, right?
Yes.
And then we got a little ramp over here. Okay. But the idea is have fun with the math. Okay, the guy's going up the stairs?
Yes.
Excellent. We've got a balcony going on there. Anyway, it's kind of cool.
I know.
Cool.
He's going to be my skill model.
Okay, let's see what else we can do. What other kind of learning we can come up with.
5, 5, 5.
And then here's a structure made of 7s and addends for 7s. Now we could count by 7s. Can you count by 7s?
Yeah. 7,
14, then what?
21.
Then what?
28.
Then what?
Huh? 28,
Yeah.
35.
Yep, then what?
Oh yeah,
Never assume that it's all mastered.
Right. 42.
Good. And then what?
49.
Then what?
And then 49. Wait, what's 49? Oh yeah.
49, 7 7s.
7 times 8 is 56.
Okay. Or you could just add another 7, 49. 9 takes the 1, there's a 6 left.
Okay.
Okay, so now we're at 56?
56, yeah. 7 times, that was 7 times 6.
So then add 7 more. Take the 4 out of the 7, there's 3 left. Look, take the 4 out of the 7, there's 3 left. See it?
Yeah.
Get 63. The wind just knocked over our little causeway. 63. Then what? Add another 7.
Wait, 63 plus another 7?
Mm-hmm. Super easy.
Wait, 67 plus another...
No, 63 plus another 7.
70?
Yeah, but what's 3 want to be? 10. Get the 7. Right?
Yeah.
Can never build enough 10s either. Okay, then what? 77. Then what? I did the easy one. What's 77 and another 7?
84.
Very good. And another 7. Calculating in his head. What is 4? See, that's the original one that got this whole thing started. What's 4 and 7?
4 and 7 is 11.
So what are you going to have? 84 and 7.
84 and 7. Or 91.
There you go. And again, you can hear the light bulb go off. Oh, right. Okay. I mean, just, that's it. As you're playing and having fun, count. And more exposures, more exposures, more exposures. It takes, like I said, at least 18 just to get from short-term to mid-term memory, and probably more than that. And then to get to total instant recall, it's up there around 70-something impressions, 72, more than that, impressions. So what we're working on here with this child is mastery, where you don't have to think about it. Where you do multiplication or addition, it's just there, right? And the way we get there is by playing with blocks and having a good time and building castles. And what are you building now? What is this thing? That it's his gazebo.
Yes, his gazebo.
His gazebo on the roof. They can hang up there and have tea. Invite his friends over.
Yep.
Hang out.
And then his friends can leave.
Oh, right. And you can watch the guys go down the ramp. Anyway. So, where do they go for more?
Crewton Ramone HouseOfMath.com for more.
There you go. Okay, 6s?
6, 12, 18, 24. 30. I promise I wasn't going to get that. 36. 42. 48.
Yep. See,
45.
What?
55.
55? With 6s?
Oh, wait, no, wait.
Okay, start over. 6, 12, 18, 24, 30. How many is that, anyway? 30 is how many 6s?
5.
Okay, and 36 is
6.
Okay.
6 times 7 is 42.
Okay. 48.
Yeah, 48.
Would be next. Then what?
48. Then.
What is 6? Wait a minute, 48.
54.
Okay, right. So 8 takes the 2 out of the 6, and there's 4 left. 54. Then what?
58. I mean 6. Yeah, still 58.
What? 54.
Oh,
and I'm adding 6.
60.
Yeah, because 4 is all happy because you get 6, right? And then what? Okay, now we're getting there. 60. Now let's get in the higher numbers. 66. Then what?
6 times 12 is 72.
Good. Keep going.
What?
Keep going. What? We're gonna stop at 12s?
Yes.
Well, where are you at? You're in the house of math. We don't stop at 12. Keep going.
72.
Then what?
78. Then
2 and 6.
84.
It's not a hard one. Wait a minute. 72.
84.
72. And 6 more.
72.
And 6 more.
Yeah, 84. 82. Oh, no, 84.
How do we even get to 80 if we're only adding 6?
Wait, where are we?
See, as soon as we get high, you start freaking out.
Wait, where are we? We're at 72.
We're at 72, and 6 more.
Oh, 78.
There you go.
Then, I already said 78. Oh, but whatever. Then, 80, 84.
There, okay, there's 84. Because there it is again. Every time it's the same thing, right? 8 and 6. There's the 4s, right? Okay, then what? Okay, so 84, then what?
84 plus another 6?
Mm-hmm.
Okay.
Why are you even doing any calculation? What does 4 want?
6.
So we're giving 4 the 6 and we get 90!
90, 96, 90.
Starts over again. Then what? 96? Then what?
102.
Good. Ooh, okay, so let's stop there. How many 6s in 102?
Dang.
Darn it. Well, let's think. How many 6s in 60?
How many 6s are in 60? 10.
Okay, so there's 10 right there at 60. How many more to get to 102? All in the head.
115?
Wait. From 60 to 102.
So it's 15 more.
Wait a minute. No, I'm talking about just doing subtraction. What's 102 minus 60?
102 minus 60?
And there you go. See, this is why 40. We do the add-ins. 40 what?
2.
42. So, how many 6s in 42?
How many 6s are in 42?
I feel like we're doing Monty Python. Yes.
42
how many?
7.
Okay, so 10 and 7 is?
70.
10 plus, okay, no, 10 plus 7
Oh,
is 7.
17.
We're counting sixes. How many sixes in 102?
17.
17. There you go. That's one way to figure it out. Okay. So, math. Just doing simple math. Fooling around. Counting. Okay, right? Building. Counting as we go. And you'd be amazed at how many times. Now, you know what we need to do is knock this whole thing down, put it away, and do some paper and pencil math. Hey, don't get too crazy. Oh, but it's the most fun part. Like I said, it's always, what's the most fun part of building anything is knocking it down. But the more mess you make, the harder it is to put away, you know. If it's going to be... Oops. Look at that, we had some cars in there. Alright, and then after we get this all put away, you wanna get the demolition on camera?
Okay. 3, 2, wait, let me break my bowl of dynamite.
Okay.
3, 2, 1.
Oh! Okay.
Oh wait, the stairway.
No. Okay. And see, this is how you know you've been playing math right there. That's how you know. Okay, so we'll come back in a minute. Alright, so look, that was quite the mess. Now it's all nicely cleaned up. And here we are practicing, right, what we just learned from building all that stuff. And there you go, right? Move your hands so they can see. So just mixed practice. Here's some algebra. Here's just some simple addition, just practicing addends. Here's some making change for 100. Here's just some simple subtraction. Super easy, fun. Again, more impressions with addends. Alright, Crewton Ramone's HowsToMath.com for more.